Hi friends, this is hopefully just a quick update video for another thing that I modeled and 3D printed that hopefully a lot of people will find useful. So this is an industrial grade mass produced injection molded drip tape barbed fitting and with a quick connect. So how this works is you basically shove the drip tape on this end, and then you turn this threaded nut here, and that clamps, like if you do it right, and if your drip tape's long enough, it clamps the tape in place. And then this barb here, this is for super high flow drip tape. That's why this is such a large barb. This is like a 1/4 inch, I think. Although, it's so confusing the way they label these. Like, this is a 1/4 inch, or what's typically considered a 1/4 inch barb. A 1/4 inch punch is for. This is the inner diameter is a 1/4 inch, but this is more like 1/2 inch. So maybe this is called a 1/2 inch barb. I don't know. Anyway, it's for high flow. This is just standard drip tape. So anyway, these things are a little expensive, although not if you buy them in bulk. However, I wanted to create one out of PLA that I could just print my own discretion and make as many as I wanted. So this is the result of that research and development. I'm really proud of the thread here, because this is like the smoothest thread I've ever made. And the cool thing about it is it's a true 45-degree thread that's fully optimized for 3D printing, so you don't have to worry about overhangs or supports or anything. And just in terms of structure and microstructure of the layer lines and stuff, it's like incredibly robust. So that was my big accomplishment here. Also, a little feature I added most recently is a vortex inducer, which is an anti-clogging feature, and also helps move the fluid a little more rapidly, which is kind of interesting. But anyway, there's a wedge on the inside. You can't really see it, but when the water comes in through the main line, it hits that wedge, and then it's through just the topology of the spiraling plane here, it gives the water a little spin, which can help with velocity and distribution, although maybe insignificantly. But in essence, it's supposed to like create more torsion or force in there that can remove clogs or break up particles. Not that you'd ever want to have things that could clog something this size in a drip tape. Also, the reason I first created this little bridge here across the opening was to give it better bed adhesion. That's actually, well, there are two flaws with this design, neither which is a deal breaker, but they're both considerations. The first is that the bed adhesion is not super great. So when you're printing these in large batches, like for production, you would either want to use a brim on the bottom, or only print these separately, and only print these separately, and don't print them together as a batch, because over time the cooling of the build plate and temperature irregularities can cause this to de-adhere from the bed. The second flaw is one that was pretty easy to fix, although this is sort of a chronic and consistent flaw. This is very thin here because of the way the topology works on the inside. You can't see it, but if you could, there's a cone shape, and unfortunately the curvature of the neck here and the cone, as it started to expand, actually not intersected but created a very thin wall that's just like a millimeter there, and that was a weak spot. So I fixed that by making this a straight bore down to the middle of here before it starts to flange out into a cone. So that's a little bit stronger. I haven't had one of these breaks since I made that modification, and I added these little wings on here so that when you're cinching the collar or nut around the drip tape, it will allow you to get enough leverage to do it nice and tight. Although I did the previous generation by hand, and I found that I could get it totally firm enough to where it would withstand even 50 psi, which was pretty intense. Though you're not supposed to run drip tape at 50 psi, it can explode, just FYI. So yeah, I found, first of all, okay, when you're using these, you want the little grip side of the nut to be at the same end as the drip tape barb. And then I found that when you're putting these on, you want to take that off first. It's just easier. And then you want to like kind of like rock the drip tape back and forth, because this is a really tight fit. I wanted it to be as watertight as possible, so it's not like the industrial ones, they just slip right on. But I made this a little bit tighter, so you got to kind of rock it, and then like once it's over the edge there, then you can twist it until it's over the edge of the barb, like that. And you want it to go farther. I can't push this any farther because there's actually a drip emitter in there, but basically you want it to go up, you know, half a centimeter or just as far as you can. It's okay if it goes all the way up to the threads. And then this slides on the back like this, and it's a left-handed thread, and then you use the little wings to lock it in place, just like that. And that basically is how that works. And let's see, what else? There's one thing. Oh yeah, I just wanted to like point out that I managed to reduce the size and therefore the material usages quite a bit. This double barb, I will say, is a superior feature in terms of gripping strength and stuff, but I wanted to keep the design as simple as possible, which is why I also I wanted it to print in place, so that was another consideration. So yeah, anyhow, this is on Printables. I'll link it in the description, and I marked as public domain, so, or licensed as public domain, so you can print to your heart's content. Thanks for watching.